The ability to store the charge is called as capacitance of the conductor.
Conductor.
Okay, now if you give charge to a conductor, now you take a conductor and you give charge to the conductor. When you give charge to the conductor, then what happens? When you give charge, the charge increases the potential,
Yes,
right?
sir.
So Q is directly proportional to V. So we can write Q is equal to C into V,
Yes, sir.
where C is a constant called as capacitance. Okay. So this
Yes,
C is equal to Q by V.
mm,
Now, if you write the unit, Q is in coulomb and potential is in volt. This coulomb per volt is called as farad.
yes, sir.
Is farad. Okay. So now this farad is denoted by F, but farad is very big unit. We just deal in picofarads or microfarads. 1 picofarad is 10 power minus 12 farad.
Yes, sir.
Practically we use in picofarads. Now capacity due to an isolated conductor. Capacity due to an
Isolated.
isolated due to isolated
Conductor.
spherical conductor. Okay, I will consider a spherical one and I will calculate the capacitance. Okay,
Yes,
now let us take one sphere. Radius is r, and here the charge is q.
yes, sir.
Q is the charge. Then what is the potential? Potential is equal to K Q
Mm,
by R.
R. Yes, sir.
Potential is K Q by
R.
R. Potential is K Q by R.
Yes,
Okay. Now capacitance C is equal to Q by V.
yes,
So
sir.
that is equal to Q by V. What is
Yes.
V? We'll write
Take you
here.
by
K Q by
R.
R. So this Q and Q gets cancelled. So that is R by
R.
K
Q.
value is 1 by 4 pi epsilon naught. So you get 4 pi epsilon naught R is the
Yes,
capacitance of a spherical conductor. Capacitance of a isolated sphere C is equal to 4 pi epsilon naught R.
R. Yes, sir.
Okay. Then energy of a charged conductor. Energy. I'm discussing about the energy of a charged conductor. Okay.
Yes, sir.
What is the energy of a charged conductor? So you have a conductor. Okay. So what is the how much of energy is stored on this conductor? That is what I'm going to discuss. Okay. Now now if you see potential and charge, you can see this is potential and charge. You can see this is the area. So from that, work done is equal to half into area of this is half into base into height, half into QV.
Yes,
But we know Q is equal to CV.
TV.
Now Q is equal to CV, so this is half into
TV.
CV into V. So that is equal to half CV square. So the work done is half
CV
CV
square.
square. Now again you can write here V is equal to Q by C. So you can write half into C into Q square by C square, that is equal to half into Q square by C. Okay, this is Q square by, or simply you can write Q square by 2C is the energy of a charged conductor. The work which you do is stored in the form of energy. That energy is Q square by 2C.
2. Yes, sir.
That is the potential energy.
Yes,
Okay.
sir.
Now, see, once you give one charge and if you are bringing the charge, then it will repel. This positive
Yes,
will repel this one. Again, as this repulsive forces, you are charging, you are doing some work. The work is stored in the form of
energy.
energy.
Yes,
Okay,
sir.
so that is half CV square or Q square by
Q square by
2C.
2C.
Okay, that is work done. Electrostatic potential energy.
Yes, sir.
Combination of combination of drops, combination of drops. So here what I'll do is I'll take n identical n identical drops, n identical drops, n are there. Each
Yes,
one is having a charge q and a capacity c. Okay, and the potential is v and energy is u.
yes, sir.
Okay, now this combine, all of them combine to form a bigger sphere. Okay,
Yes,
now
sir.
let us take this potential will is v dash. Potential is
V
v
dash.
dash,
Yes, sir.
and potential is v dash, and charge here is q
Q
dash,
dash.
and the energy is u dash.
Yes, sir.
Capacitance
Capacity
for this is
Q dash.
c dash.
Yes,
Now
sir.
n identical, if we mix, if they coalesce to form a bigger drop, then the mass of them, all this mass will be equal to this mass. So that
Yes,
means n into mass of the smaller drops is equal to mass of the bigger drop. Now this one I can write it as n into volume of the smaller drop into density is
yes.
equal to volume of
Volume
the
of big drop.
bigger drop into density. So density and density gets cancelled. So n times of volume of the smaller drop is equal to volume of the bigger drop. So n
Yes.
into 4 by 3 pi
Uh,
r cube is equal to 4 by 3 pi capital R cube. Then this 4 by 3 pi, 4 by 3 pi gets cancelled. N into R cube is equal to
N into small r cube.